Hello, good evening. So here, this is a long video of my recent project, a project I have built in microservices architecture. This will be a long video and step-by-step guide. If you really want to know what AlgoCode does in detail with detailed explanation, please watch this video. But I will also make an short video, maybe 2 or 3 minutes only, or 4 minutes only. If you just want to see AlgoCode in action, what it does, it actually coding platform just like Leetcode, and I have not used any third-party APIs. I have built everything from scratch. So if you just want to see it in action, please see the video I have listed just below of this long video. So I'll be going through step by step in this long video. So AlgoCode is a coding context and practice platform is a Django-based microservice architecture backend for online charge platform just like Bitcoin. So to be honest, I have also written a blog. You can see the blog here. So I can definitely check this. So what AlgoCode does is that what Leetcode does in the backend, AlgoCode does the same in a miniature scale. AlgoCode does not have right now the front end part, but it has the backend and it is fully deployed in AWS EC2 instance. So I will just give an overview of the architecture right now. So AlgoCode has three services actually. Right now, AlgoCode Work Service, we know what Work Service does. Code Manager Service. Code Manager Service actually interacts with the client, and uh, client can only and directly and only interact with Code Manager Service. And RC Engine Service is actually the service that handles the code submission, code execution, and it processes the result of the code submission. I'll be going through all the services right now, and these are the events RC engine can handle. So it can handle AC, accepted, WA wrong answer, compilation error, time limit exceed, memory limit exceed, and segmentation fault. These are the events the RC engine C++ search can right now handle. So again, the RC engine or C++ search is built. I have written it from scratch. No third-party APIs has been used uh, in entire AlgoCode backend. So here's some note and rate limit here. So the API by which the code submission is actually submitted to Code Manager service is rate limited 1 request per 2 seconds. Because I'm actually using 3 servers of AWS with 1 GB of RAM. So this actually I have to rate limit. I had to rate limit it, so you can only submit three submissions per minute. So this is the code submission API, code manager.algocode.site API if you want code submit. So this is actually rate limited. And I have really great documentation. Yeah, I'm proud of this documentation. So you can really get step-by-step guideline of AlgoCode here if you come on this GitHub. So now I will directly jump into here, architecture on workflow. You can see the architecture. This is the work service. So I will not waste my time explaining what service does. So this is the code manager service. So this is the submit API. So what it does that it takes the request of code submission request and it processes the data. It actually fetches the test cases from the database, test cases answer from the database, and it validates the request whether it is authenticated or not. Then, after processing the request, it actually publishes the process data to a RabbitMQ message queue, that is RabbitMQ instance. So this is the core RC engine, where C++ charge sits in between the RC engine service. This RC engine service is listening to this code submission queue, and it is consuming from the code submission queue. And once it is there is a message, it consumes the message. It actually again goes through a few steps. It processes the data. It actually writes the the test cases, the input file, output file. It actually goes through every processing. Then it activates the C++ charge. When then C++ charge is actually spawns very secure Docker container, and that Docker container actually executes the code. The Docker container is capable of handling a fork bomb, file hijacking, uh, all the common attacks we actually see executing the threat of executing foreign code in our server. So it is capable of handling all that stuff. So once the execution is done, then what does it engine does, it actually captures the output of the result. Then it compares the output of the code with the test cases, and after comparing, it actually generates a very beautifying the response, that the result we will see when I will submit a request just now, and it actually publishes the data and the result. If there is any segmentation fault, or if there is any you see time limit exceed whatever I have already shown the event, everything is the C++ charge of the search engine is capable of this. Did I mention that Python and Java search engine are the I'm actually also building the Python RC engine, and one of my friend is actually building the Java RC engine. So I will update once the algo code is capable of handling Python and Java code also. So right now, AlgoCode is fully capable of handling code submitted in C++ language, but in future updates, AlgoCode will also be capable of handling Python and Java code also. So once the result is actually generated, the Arch engine publishes the data to another queue and a result queue, and this result queue again consumed by the code manager. It consumes the data and it saves that data in a MongoDB instance, and when it saves the data in MongoDB instance, it also caches the data, caches the result for few seconds, and then the user can actually send a request to the checks result API. And the check result API is actually a short pooling API. It actually waits for 5 seconds to become the data availability. So it checks the data for the cache first, then in the DB, and then if the data is not available, then it actually waits for 5 seconds. So yeah, this is the short filling API. So once the data is available, then it actually turns the result to the client. So this is actually the overview. You can see I have actually mentioned a very step-by-step guideline and very detailed explanation. This is deployment where all these things are deployed. This is a problem list. As I have already told you that AlgoCode does not have any front end right now, so you can find the problem list. This here I have listed the link here. So I have actually added only 4 problems. So generating test cases is very boring thing. So this very easy question. This and all these things, 3 questions I have actually copied from Leetcode only. So I will also continue adding more questions. So if you come to this link, you will come to this Notion page, and these are the actually problems. And if you go to the paradigm number, then you will see the actually you have to copy this problem ID, and this is the title, and this is the difficulty, this is the description, this is the test case example, and these are constants. So yeah, so let me show you and how actually things are working. So if you come in this GitHub, the main GitHub of AlgoCode, you will get to know the a detail and step-by-step guide how you can actually submit a code request. I'm sorry, excuse me. Yeah, so this is the actually AlgoCode backend what is the production. So this the I am not going through the all this authentication and registration part. You can see this is managed by the work service. So let me get back to the So this is the auth service. Okay. So this auth service is actually hosted in AWS EC2 instance. It is also in a free server. Yeah. So actually, yeah. So this is the let me so um, let me this is the yeah, so yes, this is the actually auth service Celery image. I am actually using Celery to send the image registration email to send the email. This flower to manage the Celery. This is the API actually. This is the main Django backend for auth service. This is the PG image for this is the database for um, mm, user management. And this is Redis for caching and Celery backend. And this is actually I am also running the AlgoCode RC engine service because I only had two free server. So I had to actually run the RC engine also in same server. So here in this issued instance, I'm actually running the auth service, this auth service and this RC engine because I have had two server. And in this server, I am actually running this code manager. Here, the Docker containers for code manager are running. So I'll show you how things are actually working. So now let's actually see. So this is the auth service. So I'm not actually wasting my time to show you how actually the authentication, all these things. So now come to the main part, the most exciting part, that code manager. This is actually code manager service, and this code manager service is hosted here in this server. And yeah, so this is the another server. This is a different server, and this is different server. Okay, so now this is the code summit. Now let's see the code display. That is all the questions APIs, all the questions. So let's see the all the questions available in AlgoCode. And you see, this is the URL. You see, it is SSL encrypted code manager.algocode.site. Here, actually, the code manager, this service is actually hosted, and I have only got the algocode.site, and I am using this algocode.site domain, maybe 15 to 60 sorry 15 to 20 subdomain. I'm using maybe 10 to 15 subdomains for this algocode site. So this is the actually code manager. Algocode site is actually this one, and using this URL I am actually submitting the request to this service. So, okay, let's send a request to get all the questions. Yeah, so I have actually increased the font size to let you know that you can see the uh, the details. So you see the response is immediate response. So I'll not waste many time here, much time here. You see these are the companies. The question is asked. These are tags brute force. This is the question image, and these are accept and rates whatever. I'll show you in admin all these things. So let's not just bother waste your time here. So this is a single question. You can find any single question using, and this is the question does not find API. So yeah, I'm just this is a basic thing. Uh, okay, now uh, actually I will submit a code. So I already told you that I have already four questions in my database. That is sum of AV. This is very basic, but to demonstrate the algo code, this will be very beneficial. This is a square of Leetcode. I think we have already solved this in Leetcode. This is the array GCD. This is the GCD of using array, and this is a parent node number. So let me show you the easy one. The sum of AV. This is the AC code. So this is the AC code. So the code does? This is the problem ID, and this is the language, and this is the code. Now, what the code does is that it takes test case A and B. It takes the uh, t time test cases and um, print the sum of A and B. That's all. Uh, that's the question. Just a basic thing. So now I am sending a request to this code manager. This API actually submits the request to this code manager, this service. And what this service does is that it actually processes the data. It actually takes the this problem ID and fetches the test cases from this PostgreSQL database, test cases answers, and it also validated the my response, whether this response is validated. If everything is successful, then what it does that it actually publishes the process data, the process data, actually the test cases from the database, result from test case result from the database, and this code, and a few things from the GitHub token to a RabbitMQ instance. And this problems submission queue is consumed by this RC engine. This RC engine, I have already told you, RC engine is deployed here. So for if I show you the logs of this RC engine, let me show you the logs. This is the RC engine, okay? AC9, 1. Yeah. So you see, this is actually the RC engine log. So let me show you the result of have actually what I got here. That your response has been submitted, and this is the submission ID. So yeah, actually, whenever I am sending a request to this code manager, it actually processes the result, publishes the data to a MQ, and it actually returns me the submission ID. That's all. It does not wait for the execution. And this execution, this server, this service actually executes the code. And now this is the code result. So I have actually written a JavaScript code that what it does that it actually takes the submission ID, and it actually makes a environment as a submission ID so that I do not have to copy the submission ID each time. So here I am actually passing the submission ID to this is a code manager, the same domain, API view on result check, and I am passing the submission ID. So what it does that it actually uh, once the RC engine actually executed the code and it actually generated the result, it published the result to another result queue. That result queue again processed by the code manager, and code manager consumed the message. It actually saved the message, saved the result to a MongoDB instance, and it cached for 20 or 25 seconds. Okay, so when I'm sending a request to this API, to this code manager service, it actually first check in the cache. So if it is found in the cache, then it will be returned from the cache. Then it is it checks in the DB, and if it is not found, then it will actually waits for 5 seconds. So I have already requested it maybe 1 minute ago. So it is not in cache right now. So it must be saved in DB. So it will actually return from the DB. So it not the short polling API will not be activated right now. So the DB will be hit in this case. So I am sending a request, a code result, and you see, this is the actually structure of how the result of the code submission. This is status is success. The data in the data, there is a result, and inside the result there is another result. The all test cases first, and the verdict is accepted. The status code is 0, and the status is successful, and the error message is null. A success message is that code compiled and run successfully. And these are the some user details for to show in the front end, and this is the submission ID. So this is how things are working. So now let's send a wrong answer. Yeah. So what this wrong answer does that the question states the A and print the sum of A and B. But what I am doing here that I am actually printing the subtracting uh, instead of adding. So now let's say send a request to this code manager. Now what code manager it processes the result and it publishes the processes the data and publishes the data to a replica instance. And now you can see, okay, let me show you again. Yeah, you see, the message is consumed. The message is immediately consumed. Consumed. You can see the successful file created or later file. This is the log you can expect from the code, a remote code execution engine and container to fill time. And it took only 2.48 seconds to the C++ jars to actually jars the execute the user code. 2.48 seconds, and all the unnecessary files are deleted. And what it does that it processes the result. This is the time for C++ George, and for this is the time for RC engine time, RC engine. So after the C++ George actually execute the code, the RC engine actually takes the action. It deletes the file that it actually wrote, and then MQ code exec result publish success. Code execution result for username Mehboob connect successful published to result into. The result of the code is actually published. And once the code is published, the code manager also consumes the result, and it actually saves in the MongoDB instance. So now what if I actually check the result as the code was not correct? So let me clear it with the response. Now send the response of the last submitted request. You see, here is the result. The data result wrong answer at test case 1. So as the question says the sum, but I am subtracting, so the first test case actually failed. The output is 5 minus 5, but it was expected was 25, and the verdict is wrong answer. And status code is 0 because the code actually ran successful, but test cases were not passed. Status is successful, error message is null, success message code compiled and run successfully. This is user to submission ID. So what does a compilation error looks like? So this is a compilation error code. What I have done in this code is that um, I think I actually made some error in the okay. I think I actually did not declare a variable, but I am using it. So let's send a request. You see, immediately it has consumed by the RC engine. It took 2.33 seconds. Now, and let me show you the result of the. This is the code manager service. This is the code manager service. It actually manages. So let me show you the logs of code manager also. And this is the Postgres database. In this database, test cases are stored. In this MongoDB database, the result of stored, and this Redis is actually for caching, and this is the Django backend. So let me show you the logs of the Django backend. If 8 to 9, you see, these are the see the DB hit. The cache was not hit. Code result consumed success. Code result actually consumed, and result consumed success. So once the RC engine actually publishes the result, the code manager actually consumes the result and stores the result in MongoDB. So now, as you see, I have not checked the result of the compilation error. You will see that this is a code manager service. This is a code manager service, and this is the RC engine and the C++ charge. In this code manager service, you will see that DB hit will be, you will see the DB hit here. So now I am sending a request. Yeah, you see DB hit because cache actually was deleted. Code result consume success and DB hit. DB hit for submission ID. This is submission ID. Okay, so now see the how actually compilation error looks like. The status code is 1. Status is actually compilation error. Error message. I see that there is an error message. If there is an the status code was 0, then we see that there are no error message. It was actually null, and there was a success message. But as the status code is 1, there is an error message, but there is no success message. What is the error message here? So the error message is that main CPP error C. You see, C was not declared in this scope. Sum A plus C. Yeah. So I actually declared a variable and C that was not declared. So compilation failed. So this code actually didn't run. Now let me show you that time limit exceed. What does a time limit exceed looks like? So this code I have actually running a infinite while loop, but the containers, the sibling container, are only meant for to be live only for 6 seconds. So if a code is actually taking longer than 6 seconds, uh, longer than 5 seconds, then it will be considered as time limit exceed. So let me send you request. You see the code submission, it is actually processing the data, and it has actually processing the data. You see this is actually took 6 seconds. So it is actually the code actually running and running. It did not terminate it. So as it was running, the process was running. So what the C++ RC engine, what RC engine did that, it actually killed the process, because I have already mentioned that any container can took this much of time. So any user cannot actually use the resources for infinite time, whatever they cannot do anything illegal with their code. So if the code is running more than 6 seconds, it will be stopped. It will be passed a kill command, and the container will be stopped. And so this is the code result published, and you see the code manager is also consumed the result. And now what if I check the result, create the response, you see, yeah, you see this is the runtime error. Status code is 124. Docker sends us a status code for 124 if it is run type or time limit exceed. Status is time limit exceed, error message is time limit exceed, and success is null. And what if I just send you show you a segmentation fault? And what I have done in segmentation fault is that I have actually, in this code, I have actually declared an array of very small size, but I am actually accessing the array of arbitrary value. So this is actually very big and large number of index. So this is actually not valid to access the index that is not actually declared. So this is actually definitely an example of segmentation fault. So let me show you how things are actually working here. I'm sending a request, code manager actually processed it, and you see the RC engine actually executing the code. It took 3.38 seconds. It actually published the result. Code manager again consumed the result and it actually saved in the MongoDB instance. And now I am actually see the result. You see cache it actually in the cache. So you see this is the segmentation fault. Status code is 139. Status is segmentation fault. Error is index out of bound, code dumped, because it was actually accessing an index that is actually not that has not been declared. So it is index out of bound. There is no success message. So memory limit exceed is again same thing, because I have actually set memory limit for 200 MB. So the code does not actually code is attempt to the code I have written actually does not exceed the 200 MB. So I will actually get time limit exceed here. But if there is a code that actually tries to consume more than 200 MB, then it will actually receive a memory message. So this is very this was the very easy question. Now let's show the palindrome number. So this is the palindrome number, and you see this is a very correct code of palindrome number. If I send a request a palindrome number, you see code manager actually published it, processed and published, and RC engine actually processed. Oh, it only processed 2.35 seconds. It only took 2.35 seconds, and it published the result also, and it also consumed the result and saved it in the review. So it is really very fast. Now let's get the result. You see DB hit actually, it was declared from the cache. You see all test case passed, because the code actually is correct. It is AC code, and there is, you see, strategy successful. There is no error message, as this the stress code is 0. Now let's see and how a wrong answer of the palindrome number works. So everything you see, I have set every wrong answer is code, all these things here. So now this code actually is not correct. I have I have made something wrong here. So yeah, here is the wrong thing you can see. So instead of I actually get the division of 10, I am actually dividing it by 100. So this is actually not correct algorithm. So now send request. The code manager published is processed and published, and what? Yeah, RC engine also processed. It is also it take 2.56 seconds. It also code manager also cache the result. So this is the server of RC engine, the C++ charge, and this is the code manager that actually manages the it. I am actually you see the code manager.algocode site. This is actually of uh, this is interacting with this code manager server, not this one, because this is actually there is no API to interact with the RC engine. It is actually hidden, and no client cannot directly access code manager. It is only accessible through message queue. Okay, so this URL is actually interacting with code manager APIs only. So now let's see the wrong answer of palindrome. And this is the result. Your response. This is the result. Yeah, you see the deviate. Wrong answer at test case one, because you see it must be wrong answer at test case one, because body because it was the algorithm was not correct. So it was because that's why it could not go through uh, all the test cases. And once a test cases is actually found wrong, mismatch, then immediately a response is generated, the result is generated. It does not compare all anything other response, other test cases. So it as it found the test case number one is wrong, then it immediately return the result. So the expected output was false, but expected output was true. Expected was true, but output was false. So, but it was wrong answer. So, yeah, so this is the code manager. It is actually, and okay, so now let me show you um, how actually the rate limiting works. So as I told you that it only allows this code submit API only allows 3 requests per minute. So now I will be trying to send more than 3 requests. So now I have sent one request, two requests, three requests. You see, code manager is processing all this. Now again I am fast. Yeah, you see the at the in the fourth number of request, the request is rate limited and wait time is 11 seconds. Again, I am sending request. It is wait time is 1 second. Again, I am sending one request. It actually took the request. Now again, if I am send another request, it is actually it tells wait time is 11 seconds. Again, I am sending a request. It tells wait time is 5 seconds. So what it does that it basically allows one request per 20 seconds. So this request will be processed. You see, this request is processed, but now no request will be processed because I am again sending another request within 20 seconds. So you see, no request is processed. No request is processed. No request is processed. Yeah, this request is processed. Now, if I send another request, yeah, you see, wait time is it says you cannot see that code manager is processing anything. Code manager does not process the request. So this rate limit is I have applied the rate limiting. Uh, Now you see this is actually processed. This is actually processed. If I send again, the API is rate limited. So I have actually implemented this rate limiting algorithm using a token bucket algorithm, and I have applied the rate limiting globally in Django middleware. So it actually applied globally. So and it only looks for the rate limiting in this API only, API view on code submit. So there is no rate limit is applied on the check result or the question see question result. And you see all the input submission request has actually processed one by one by RC engine service. So there is no issue with the RC engine, but as I do not want to overwhelm my RC engine as it is only a 1 GB instance, so this is really very unfair to not to implement rate limit. So um, uh, so that's why I have implemented the rate limit so that my RC engine is not overwhelmed. So okay, if I just show you the resources, so this is the RC engine resources. It takes 400 MB right now, and um, these are the containers you see. This is the auth service. This is the container for auth service I have already mentioned, and this is the actually container for RC engine. Okay, so and it is this is the container for Portainer. So I'm actually using Portainer to actually this is very inconvenient to every time log into the server. So what I have used that I actually implemented Portainer so that I can actually monitor everything from Portainer portal. So I'll show you them and I'm actually using npm the engine exposure manager to manage all the subdomains of because I have only pursued one subdomain, one domain that is algocode.site, and I am using this algocode.site subdomain in various cases. So this is really very great documentation. If you come in this GitHub, you'll see very step by step how things actually working. So I have already mentioned that this is the what questions list, and now oh, okay. So this is my actual GitHub. You can see. Okay, why this is open? Okay. So this is actually the documentation page for auth service. I have already mentioned the auth service is this one. Let me show you the auth service. Yeah. So this is the auth service. Documentation for this auth service is this one, and it is running auth doc algocode.site, and this is the documentation um, for the code manager service. You see, it is running on cm.algocode.site. So I'm actually reusing this algocode.site to all the services or all the things I need to access. And you see, this is the admin page for code manager service. And here you see the questions: random number, find greatest common divisor of array, square take sum of AB. So if I go into the and you see there's a questions companies which companies are asking Meta, Zeta, Amazon, and Flipkart. And these are the questions, and these are the tags, arithmetic, array, brute force, loop, math, and these are the questions. So if I go into the questions, you see, this is how actually the questions are. I have actually these are the few test cases, and um, this is the question description, and this is the test case actually. You see, I have actually I have managed to write 20 test cases, and these are the result of all the test cases, and these are the constants. And companies are asked by Amazon, Flipkart, whatever, and these are brute force and loop. So this is actually a code manager. Code manager is the service actually. It manages the database for the questions, and this is the admin for the what service. You can see, and these are the user. You can see this is the Chester, and you see the this is a auth.admin.algorithm, and every domain is actually secured. It has SSL certificate. So if I go to cm so algo code website, then this is the portainer for uh, algo code service. This is the algo code. I actually forgot the dashboard. And if I go to the what, it is what portainer.algo code site. Yeah. So this is the portainer for this algo code service. You see. So I'm actually managing all this stuff using the portainer. because sometimes you know we can directly see things when we do not want to, or we cannot access to our server. So this is a port owner. I actually forgot the username. And yeah, and I'm using npm Nginx Proxy Manager to manage all these subdomains. So this is basically it for the long video. So you can, what you can do that you can see all the services. I have really very great documentation for each services. You can see here. You see. So if you really want to check out, you can check all the services. I have wrote service a specific um, what document git readme, so you will not be lost. And this is the RC engine has currently has a C++ version, and I'm actually building the backend, sorry, Python jar, and one of my friend is actually working with the Java jar, so I'll be updating soon when all the other jars are actually sorry, developed. So this is it for AlgoCode. And this is the I'm actually using two servers because I don't have um, any more servers. You can see, and yeah. So this is it, guys, for AlgoCode. And I have tried to go through long. I have only made this long video. If you are actually interested to see any how things are actually working. So now the question is how you can actually um, submit a request to AlgoCode. So what you have to do, you just have to go to the this AlgoCode GitHub, and you will see a step-by-step guideline how you can actually uh, submit a request to the AlgoCode. Okay, first you have to registration. I have very detailed guideline how you can actually actually make a registration. Then actually how a username, email, password, etc. for registration, and very detailed guideline. And this is the code submission. You can see how this is really very great documentation. You can do the step on how you can actually make things happen. This is the problem ID. You see, I think you have already seen this. This is the problem ID, lang and code. This is the problem ID, lang and code. So this is the example. So you will not feel lost. So if you really want to submit, make a code submission, then you can really follow along this report. So if you, as the AlgoCode is fully developed the backend side, if you really want to make a front-end part for this, you are most welcome. You can email me uh, anytime, and we can collaborate to make a front-end or plan for AlgoCode. Thanks so much. Have a good day.